plane curve, there's a plane loop. And now you can ask questions of why you are assuming the loop to be like this. Why not any other shape? You can assume any other shape. You can assume any other shape. But why I'm preferring circle only? To get answer. There's a long wire. So there's a loop. And now you take every point on the element here. How b bar like this. Let this be dl. Angle between b bar dl. So integral of b bar dot dl equal to mu naught I. So what is the current enclosed? I, that one. So this should be everywhere. B bar is parallel to dl bar, so cos 0 degrees. Net current enclosed by the loop I plus I. B is constant at all points, so I'll take it outside. Cos 0, this should be. Now this is mu naught I. What is integral dl in closed path? 2 pi r. We got Mansfield due to long wire, no? To get the same answer, to conclude same thing, what we should do? We should go for the mathematics, no? You should be very good in mathematics. Whatever the Amperes circuit law, it will tell us the answer very easily. Some students are, why you are assuming to be like this? I'll assume the plane curve instead of circle, no? I'll assume like this. Will you get answer? Will he end up with answer? What's wrong with him? There's a loop. There's nothing wrong in him. You'll not get answer. That's all. So is it Amperes circuit law wrong? No. You assumed in such a way that you calculate B bar at every point. So B bar here will be like this. So B bar at this particular point somewhere like this. B bar here. B bar here like this. So at different points, the value of B bar will be different and the angle between them also different. So what happens to this diagram? How you end up? You'll end up something like this. B1 dl cos theta 1. B2 dl cos theta 2. B3 dl cos theta 3. So on, mu naught I. LHS can never be solved. So what was the problem? We didn't assume suitable the Amperian path or the loop or the curve. We didn't assume that one. So therefore, whenever you are assuming a loop or a curve, what you should take care? You should take care that the value of B bar should be parallel to DL and B should be constant at all points on the loop. Then only we'll end up with answer. So similar to Gauss law. So assuming Amperian path. So different names are given. Assuming Amperian path or loop. So what are the conditions? B should be parallel to DL bar at all points on the loop. What about second condition? B must be constant. B must be constant at all points on the loop. If you follow this much, then the answer what happen? Then it will end up like this. Then you can integrate, no? The B will come outside. Then you can integrate. So therefore now, what is the entire problem solving? You will get a current carrying structure. Then looking at current carrying structure, what will happen? You should assume a suitable Amperian path or suitable loop so that what happen? Easily you can integrate and get the answer. So what is that Amperian path or loop? Shall I say it's an imaginary thing which you are bringing to understand the concept clearly? It's an imaginary thing which you are bringing. So what should be the shape? As when you are assuming shape, I'm going to follow the points 1 and 2. So there's a use of finding out Ampere's circuit law, how we can use Ampere's circuit law to find out the field due to current carrying structures here. Okay, let's take the next solenoid. Already we discussed field due to solenoid. No? So once again, with the help of this Ampere's circuit law, we'll find out. A solenoid. Already we have some idea. So this is the